Hello everyone. Let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Question 1 says if V is a non-zero vector of dimension 3 cross 1, then the matrix A, which is defined as V multiplied with V transpose, has a rank. Okay. So they are asking the rank of this matrix A, and here V is defined as a non-zero vector of dimension 3 cross 1. So okay, so V has 3 rows and only one column, then it will be 3 cross 1 matrix. Let's assume V has a value A, B, C. In general term, we can assume V is an ABC is a column vector. So let's find the transpose of this vector V, which is just simply a row vector, sorry, a row matrix. And now we have to find the matrix A, which is defined as V into V transpose. So we have V, vector V as A, B, and C. And let's write the transpose here, A, B, and C. Now let's do the multiplication and find the resultant matrix. Here it is 3 cross 1, here it is 1 cross 3. So in the output, after multiplication, we are getting 3 cross 3 matrix. So we are getting 3 cross 3 matrix. So here the first element will be this first row multiplied with this first column. So it is just A into A. Now in the second element, this A multiplied with this B. So it's an AB. Now in the third element, this A multiplied with this C. So it's give AC. Now for this second row, this B multiplied with A, so we can say AB. Now this B multiplied with B, so we can B into B. Now this B multiplied with this C, so we can say B into C. Now in the last row, we have C multiplied with A, so we can say AC. Now C multiplied with B, so we can say BC, and C multiplied with C, so we can say C into C. Now we have to find the rank of this matrix. So we have to reduce this matrix, and now we can if we can take A out from this first row and B from the second row and C from this third row. So what we are getting, let's take ABC here, right, let's write equal to, if we take A from this first row, B from this second row, and C from this third row is common, so here we are getting A, B, C, again here A, B, C, again here A, B, C. Now you can see these three rows are identical, so we can reduce these two row in the form of 0 0, and we just end up with this first row ABC. So we can say that the rank of this matrix is just simply, let's say rank of A is just simply 1, because here it is only one row which is linearly independent, but these two rows are linearly dependent on this row. So we can say that the rank of this matrix will be 1. Okay, let's solve question 2. Question 2 says for an orthogonal matrix Q, the valid equality is, okay. Here it is given Q is an orthogonal matrix. Now the definition of orthogonal matrix says that if we multiplied any orthogonal matrix with its transpose, then in the output we get the identity matrix. Okay, so now the option A says the determinant of this orthogonal matrix Q is 0. So it is not 0, but the determinant of orthogonal matrix may be plus 1 or minus 1. We can check from this condition. Let's take the determinant both the side. So determinant of A into A transpose is equal to the determinant of this identity matrix is just simply 1. Now we know that the determinant of A and A transpose are the same. So here we can write the determinant A whole square, because this both are both have identical determinant equal to 1. If we solve for the value of determinant, then we are getting plus or minus 1. So option A is the wrong statement. Now option B is, says that the transpose is equal to the inverse. Yes, it is the property of this orthogonal matrix. If we multiply this equation with A inverse both the sides, so what we are getting just simply A transpose equal to A inverse. So for any orthogonal matrix, it transpose and its inverse are identical. So option B is the right one. Option D is the also wrong. Option C is the also wrong. Okay, let's solve question 3. Question 3 says 5 cross 7 matrix has all its entries equal to minus 1. The rank of the matrix is okay. Here we have given a matrix which is 5 cross 7, which is 5 rows and 7 column. 5 cross 7, and it is given that all its entries equal to 1. Now it does not matter how big the matrix is, because all the elements of this matrix are identical, so it does not matter how much the matrix is big. Oh, because these rows are identical with this first row, these all rows are identical, so we can reduce this all remaining row as in the form of 0 0 0 by other operation, by some row operation. So we end up with only this first row which is non-zero. So we can say that the rank of this matrix is just simply this uh, 1, because we have only one linearly independent row. So we can say that the rank of this matrix will be 1. Okay, let's solve question 4. Question 4 says the eigenvalue of a matrix. Okay, we have a matrix and we have to find the eigenvalues. So here it is a 2 cross 2. So it is easier to solve the characteristic equation. We can also use the properties. Let's assume lambda 1 and lambda 2 are eigen values of matrix. Let's call it matrix A. Then lambda 1 plus lambda 2 will be the trace of this matrix, which is A plus 1, and the multiplication of both eigenvalue, it's just simply here the determinant of this matrix, which is A minus A, it is again 0. So now from the option we can say that the option A is the correct eigenvalue of for this matrix, because the sum of these two values is give A plus 1 and the multiplication of this value give the 0. This both condition is satisfied by only option A. So we can say that the option A is the right option. Okay, let's solve question 5. Question 5 says the number of linearly independent solution of the system of equation. Okay, they're asking the number of linearly independent solutions. So simply we have to find the nullity or the null space of this coefficient matrix. So let's write. Okay, let's write augmented matrix. Here we have homogeneous system. So now we have to reduce this matrix by some row operation. Let's R2 minus R1 becomes new R2, and R3 minus 2R1 will be new R3. So after this two operation, what we are getting here in the first row is remain as it is. Now in the second row, we have to subtract the first row from this second row. So here we are getting 0, here minus 1, here minus 2, here 0. Now in the third row, we have to subtract twice this first row from this third row. So here 0, minus 2 and minus 4, again 0. Now we have to do further one operation, row operation, to reduce this matrix further. So let's R3 minus 2 times of R2 gives new R3. So let's write after this operation what we are getting. 0. The second row will remain as it is. Now the third row will be here. The first entry is 0. Here we have minus 2 and we are getting plus 2 from this second row because we have multiplied with minus 2. So here we are getting 0. Now here also we are getting plus 4. Already we have minus 4. So again we are getting 0 and here we also get 0. So now we can say that the rank of this matrix equal to 2 and the nullity we have to find the number of linearly independent solution. So we have to find the null space of this vector. So how to find? Just subtract the dimension from just subtract the rank of the matrix from the dimension of the matrix. So 3 is the dimension because it is a 3 cross 3 matrix and we are getting the rank agent 2. So we get the null space equal to 1. So null space equal null space is also indicate the number of linearly independent solutions. So here the only one solution is the linearly independent, or in the other term we can say that the x3 is the here free variable. We can take the any value of x3 and still this third equation will be satisfied. So we have to assume x3 equal to t and t is belongs to any real number, and this we can find the x2 and x1 in some terms of t, so which are linearly dependent on this first vector. So we can say that the only this vector is sorry this solution is the linearly independent. These two are dependent on the first. So the correct option is the B for this MCQ. Okay, let's solve question 6. Question 6 says the rank of the matrix. Okay, we have to find the rank of this matrix. So simply we have to reduce it by some row operation. Okay, so let's simply what we are doing is R3 plus R2 will be new R3. So what we are getting, the first row will remain as it is, second also remain as it is, third will be here 0, here 4, here plus 4. Now we can see that the this first row and the third row are linearly dependent. So let's reduce, we can reduce it further, but we we can say from here that the rank of this matrix is 2 because these two rows are linearly dependent and these two rows first and second are linearly independent to each other. So let's R3 minus. So after this operation we are getting simply just matrix as now. We can see that this first and second rows are non-zero, so the rank of this matrix simply just 2. So option A is the correct one. Okay, let's solve question 7. Question 7 says the eigenvector of a matrix. Okay, we have a given matrix which is a 3 cross 3 and they are asking about the eigenvector. Okay, so same procedure that we did in the some previous example. So here if let we multiply this matrix with its eigenvector, then in the output we are getting the same vector but multiplied with some scalar. Here this scalar is the eigenvalue eigenvalue and this x is an eigenvector. If this condition is satisfied, then and then we can say this x is an eigenvector of this matrix A. So we are going by one all option. So let's first start with option A. So here let's write matrix A. Okay, so we have a vector in the option A is 1 2 1. Let's do the multiplication. What we are getting here, the 1, here 2 plus 6 plus 1, so we are getting 2 plus 6, 8 plus 1, 9, and here now in the last entry we are getting here it is 0, so we are getting 8, sorry 4 plus 4, 8, so we cannot find any such lambda such that we can reduce this vector in the form of 1 to 1, which is our vector prior to the multiplication. So we cannot find any lambda. So this vector is not the eigenvector of this matrix. Let's check for option B. Option B, we have vector. Let's do the multiplication. Here we are getting 1. Here 2. Okay, let's do here. We are getting 2 minus 9 by 2 plus 1. So minus 5 by 2 plus 1. Okay, we are getting again minus 3 by 2. Now in the last entry, we are getting, uh, let's do here, minus 6 by 2 plus 4. So here we can say it is in 3. We are getting simply just 1. So now you can see this matrix itself is repeating here. We can say here the scalar is 1. So we can say that this vector given in the option B is the eigenvector of this matrix A. You can also verify option C and D. They will not satisfy this condition, this first condition. So the only option B is satisfying this condition. So option B is the correct option. Let's solve question 8. Again they are asking about the rank of this 3 cross 3 matrix. Again we have to reduce this matrix by some row operation. Let's R3 minus 2 times R1 gives new R3, and R2 plus 3 times R1 will be R2. And after that, after this two operation, the first row will remain as it is. Now the second row will be here we have minus 3. We are getting plus 3 from the first row. 0. We have plus 3 here. It is in plus 3. And we are getting minus 6. So we are getting again minus 3 here. Now here we are getting minus 3. Now in the last row we have 0. We are getting plus 4. We have 2 plus 6. And here we are getting again plus 6, because we have to multiply this element with minus 2. So we get 2 and we have to add up in this 4. So we get 6. Now again you can see this row and this last row are linearly dependent. So again we reduce this last row in the 0 0 form. So we can say that the rank of this matrix is 2, or in other words this matrix is rank deficient by 1. So this is a 2 as a rank of this matrix. So option A is the correct one. Okay, let's solve question 9. Question 9 says the eigenvector of this true cos 2 matrix is R. Okay, again we have to find the eigenvector. The same concept we used in the previous question. So here Ax will give the lambda x. So let's go one by one from all options. So let's start with option A. So here 0 and 1. So let's do the multiplication. Here we are getting minus 1. Now here we are getting 1. So we cannot take any scalar out from this minus 1 one vector, and we still get this vector. So it is the not eigenvector of this matrix A. So let's check for option B. We have 1 0, here it is 0. So let's do the multiplication. Here 1, here we are getting again minus 1. So now again you can see we still not get any scalar lambda to make this vector in this form, a into, sorry, lambda into x. So let's move on the option C. Here we are getting 1 1. So here we are getting 0, again we are getting 0. Now we can again not take any scalar from this matrix, sorry, this vector, to make it in the form of lambda into x, because it is in 0 0 0 vector. So we again not satisfying this condition. So let's move on the option D. So let's do the multiplication. Here what we are getting 1. Okay, here again we are getting 1. So 1 plus 1 will be 2. Now here we are getting minus 1, and again minus 1. So we are getting minus 2. Now you can see if we take 2 common, so we are getting just simply 1 comma minus 1, which is the same as this vector. So we can say this is the correct eigenvector for this matrix. So option D is the correct eigenvector for this 2 cross 2 matrix. Okay, that's it. We have done. Thanks for watching this video.